Welcome grade 10s, welcome to yet another wonderful, awesome show, all right, for you guys to get ready for, all right, the June exams that are coming up. I know that some of you don't want to hear that, but right, we're ready to work. I hope you know the routine by now. I hope you've got your textbook with you or your tablet, whatever you are using, all your notes, all your resources there, because we're going to be asking you questions. Okay. Today we're going to focus on transpiration experiments. Now, if you can remember last week, all right, last week we looked at what the whole process of transpiration. So we looked at how water moved through roots, right, up the stem, and then to this leaf, and then from the leaf, right, water was then released out of the leaf. Now, what we're going to concentrate on today is the whole how to conduct an experiment. All right, so we're going to be looking at experimental design. So if you have a look on the board in front of me here, what we're going to show is we're going to show you that transpiration occurs. All right, oh, we need to always forget the pen in the beginning. Okay, we're going to show you that transpiration occurs, and we're going to, and I hope you can remember that from last time, because we dealt with that the last week, is what factors, right, and we were talking about external factors, right, are going to affect the rate, which is the speed at which transpiration occurs. Now, before we even start, I'm going to give you 30 seconds, maybe a minute, right? And I want you to think of, last week I said to you that the definition of transpiration is an important definition that you need to know. Okay, so I'm going to give you 1 minute. I want you to give me a clear, concise definition of what transpiration is. Your time starts now. I hope you got the right definition. As I said to you last time, it's very important that you understand certain terms, terminology, right, when it comes to life science. What did I want you to be able to write? Right, first of all, transpiration occurs, okay, through the upper parts. Right, when I say upper parts, I know it seems a bit vague, but what we're talking about, sometimes transpiration occurs through the stems, right, but most importantly, through the leaves. So we say upper part because stems is a part of the upper part of the plant, but most of the transpiration is going to occur through the leaves. Okay, so it occurs through the upper parts of the stem, but what is it? It's the loss, and this is the most important, of water vapor. Okay, so in your definition, the most important thing I needed to know is that we lose water in the form of water vapor through the upper parts of the plant, stems or leaves. If you want to be more specific, all right, you can obviously then use the word stomata. Okay, so what is transpiration? When we do any kind of transpiration experiment, what we do, we're going to concentrate on how fast, all right, transpiration occurs with external factors. But if you want to do a simple experiment, all that you do is you take a plant and you tie a plastic bag all right, around the plant. And then what will happen is, it's the same as when you guys boil a kettle at home, and maybe you put the kettle underneath a kitchen cupboard or something, okay? Because what happens is, the steam from the kettle rise, that's vapor, it's steam, and as soon as it hits a surface, it changes to water droplets. That's the same thing that you can do. It's a simple little experiment. You put a plastic bag around a plant, and all that you do is you leave it you don't even have to leave it in the sun, you just leave it there. When the plant loses that water vapor, the water vapor is a gas. But as soon as it hits a plastic, why do we use plastic? Because it's see-through, right? If it's see-through, that means I can see it. Something's very visible. And as soon as it hits the plastic, that water vapor will change to water droplets. Okay, and then what will you see around the plastic? You will see all of these different water droplets. So just trying to prove that transpiration occurs through the upper parts. Remember, I didn't say particularly leaves. It could also go through the stem, right? That's an experiment that you can use. But the experiment that we're going to concentrate on today, right, and I'm going to give you, all right, a little bit of time here. The experiment that we're going to concentrate on today is going to be how or what external forces, outside forces, right, are going to have an effect on an experiment. Okay, so what are we going to do? We are going to set up an experiment. When we set up an experiment, we need to have certain guidelines, right? What I want, I'm just going to give you 1 minute. I just want you to write down the word. What I want you to give me is, what do I need, what steps do I need to follow, right, in order to make or set up and to, all right, run through my experiment. So 1 minute, all right, and your minute starts now. Okay guys, I hope you remembered that in order to do this, you had to go back right to the beginning of your grade 10, probably your textbook, where it dealt with biological skills. Okay, so when I'm setting up an experiment, I hope you guys had these. All right, what did I need to have? Look at the points. I needed to have an aim, a hypothesis. Did you have a list of apparatus, method, results, observation, all right, and a conclusion? So when I start off my experiment, we got to have an aim, and an aim means a purpose. And usually the best way to see what an aim is, it always starts with the words to determine if or to determine which. Okay, so today what are we going to look at? We're going to look at how do external factors affect the rate of transpiration. So my aim, if I've got an aim is a goal, right, where am I going to? My hypothesis here is a prediction, and very often I find this is the one that you battle with the most. Hypotheses are short, they're very concise, and they are not a question. They never a question. You're never asking something. You are making a prediction. For example, when I get up this morning, it is going to be cold today. It might not be cold, but I'm making a prediction. I might be right or I might be wrong. So my hypothesis, right, is going to be my prediction. Now today we're going to be looking at apparatus. When I conduct an experiment, it's the things that I'm going to use. It's either things that you might have in your house or it might be things that might be in your laboratory. All right, those are the things that I'm going to use. Now, when it comes to the method is how I'm going to do it. Now, when you write out your method, please remember, you always use bullet points. And the most important thing is that it must follow an order. All right, you can't just go from one point to the other. It must be systematic, right? You can't say, oh, okay, I put it in the sunlight. Oh, then I went to fill the beaker with water. How you do it is simple, all right? How do I do it? Step by logical step. When I do an experiment, what am I looking for? I'm gathering results, right? So what I do is, today you'll see, how can we do results? We get a result, something happens. What do I do with those results? I can put them in a table. I can put them in a graph, right? So somehow I get the information that I get from my experiment, and I need to put it in some kind of data. The difference here, the last one, the difference between observation and conclusion. Observation is what I see. It is different to a conclusion. A conclusion, right, is what is an answer to my aim, right? So what external factors? These are the external factors that are going to play a role. So when I come to my conclusion, very often we tend to put our conclusion into an observation. No, an observation is just what I see. A conclusion then will give me the reason, right, for what I am seeing, for what I am observing. So today we're going to do, all right, a transpiration experiment. And the whole transpiration experiment, all right, is going to go, right, about external factors. Now, when setting up an experiment, there are a few things, right, that you need to keep in mind when we do this. And they are the following. Okay? The difference between an independent variable and a dependent variable. Independent starts with I. All right, so during the experiment, it's the things that I am in control of, which I, all right, can do. Whereas a dependent variable, all right, those are the results. Okay, those are your results. So independent is the factors that I can control, whereas the dependent, all right, is the results. Now, the difference here, the problem here, okay, the problem is these two things, okay, these two factors, specifically these two words. You can see they look the same, but they are very different. A controlled variable is different to a control. My controlled variables is what? Controlled variables are the things, right, that I must keep the same. How do I mean by that? Right, say for example, I want to test something, let's go test something about a plant. And now I put one variety of plant in this pot, and I put another variety of plant in that one. No. What I must always do is, where I can, everything must be the same. I take the same type of plant, same type of plant. If I have to put it in the sun, where do I put them? Both in the same place. If I have to water them, what do? I give this one 5 mils of water, I give that one 5 mils of water. Okay, so a controlled variable means what must be done, all the things that must be the same to ensure accuracy. A control, when I set up my experiment, I don't need a control for all my experiments that I need to do, okay? But what an experiment is I set up for what I am testing for. Okay, all right. A control I take out. I'm going to use photosynthesis as an example. When a plant photosynthesizes, it needs light. Okay, so what I do is How do I know a plant photosynthesizes? I take it out, I put it in the sunlight, and then I can do certain tests that at the end I can conclude that photosynthesis occurred because of sunlight. So I've got to just make doubly sure that it's sunlight and not anything else. Okay, so my control means, what would I then do? I then set up another leaf, so I can use the same leaf, and what do? I put it in the dark, all right? I take away the sunlight. So whatever factor that I'm testing for, that must always be in my experiment, and then my control, right? My control means that I'm making sure that what I'm testing for, that the independent variable that I'm choosing, that is what's causing, all right, the changes, and not something else. Okay, guys, so I hope you now know, right, the procedures that we're going to need to follow, when we're going to do experiment, we're going to run through experiment that's very important for your transpiration. But before we do that, we're just going to have a quick break, and we're going to be right back with how to do your transpiration experiments. Okay, hope you stretched the legs, all right, and got everything ready, and you've got everything out in front of you. We're now going to start to look at an experiment, right, where we're going to measure the rate, the speed, right, at which transpiration can take place, but we're going to have the different external, all right, factors that are going to come into play. But before we look at that, I want you to have a look at a device that is up on the board here. Right, it's a new word for you. Oops, sorry, I'm going a bit too far. This is called a petometer, right? And I want you to know the name of it. This device is used, right, in how we measure the rate at which a plant transpires. Okay, follow me on the board, and I'm going to show you how you set it up. Okay, transpiration, let's start with our leaf. What happens here? Now have a look. Transpiration is the movement of water in the form of water vapor, usually out of the upper parts. Okay, so what's happening here is water is going to be released. Now, what we're going to find all the way down here, you should remember, is a tissue called xylem. Okay, now this little structure, this petometer, as you can see, is set up in water. All right, is set up in water. Because we only use the leaf and we need to control things, we need to ensure that water constantly flows right into the xylem. If you can remember, it was called transpirational pool. We looked at it when we looked at how does water move up the xylem. Okay, so what is going to happen is we want the transpirational pool. Now remember, water sticks together, sticks to each other. So when water gets lost out of transpiration, right, what's going to be there? All this water over here is going to be there, all right, to take its place. Now, what you will notice is a little thing over here. This is a reservoir. This is a little tap. And what we need this is my control. All right? What do I mean by my control? Not my control of my experiment. This little valve, I can open and close to ensure that there is always water here. All right? At the bottom here, we've got a beaker of water. So we've got a constant, now look at the blue. We need a constant flow of water. Now, when I set up my twig, when I put up the branch here, this is a very tricky experiment because what I've got to do is I've actually got to perform this whole experiment underwater to set it up. Even though you see this little thing called an air bubble over here, that air bubble I only put in after, right, I've set everything up. When I set everything up, I don't want an air bubble because if I get an air bubble, the air bubble might get stuck somewhere in the plant. And if it gets stuck in the xylem of the plant, then the water can't get up then the water can't go out via transpiration. So I need to make sure that we call that my experiment is watertight or airtight, that there are no air bubbles. Okay, so the whole thing about transpiration is this continuous flow of water. Now, what are these things over here? It's called a volume scale or a calibration or even a simple thing called a ruler. Okay, when I set up my experiment, I'm going to blow a little air bubble into the tube. An air bubble is something that I can see. Now, if you have a look at the back here, do you notice it's a ruler? What we want this air bubble to do, speed implies movement, right? Speed implies movement. So what this little air bubble is going to do is, or what we want it to do, we want this air bubble to move. Okay? We want the air bubble to move. How quickly it moves or how fast it moves, right? That is what we are going to test. So we can't see the water vapor leaving the leaf. We can't see it. But if I put an air bubble with this, like a backing behind it, I can look at that air bubble and with a stopwatch, what can I do? I can time it. I can get it to move. And the movement is what I am going, all right, to measure. So how much does it move in a certain amount of time? Now, when we look at this petometer, right, I'm going to show you two pictures below. These are also petometers. So what might happen is your teacher might give you an experiment, or you might get an experiment in an exam, and you look at it and you thought, that looks nothing like the petometer that I was showing. There are different varieties, okay? And what is always your clue? This. As soon as you see a leaf with some water, but measurements, what's the only experiment that we're going to use where we want to see how fast we want to measure something is the experiment that we are going to conduct. Have a look here. Here's another one. What is your key again? There's your ruler, because we need to measure. And how am I going to see it? There is my air bubble. So all three of these diagrams are petometers, okay? A petometer. And you will notice they all have something in common, right? There's a place for my chute. They're all filled with water, no matter what. So continuous flow of water. And somewhere there is something that can measure, right? That can measure my little air bubble to see how it's going to, right? To see how it's going to travel. Okay, so now when we look at the experiment, guys, let's start at the top. Okay, we want to measure how fast transpiration occurs. Now, our experiment that we're going to look at, let's start with the aim. Remember, my aim is my direction. I want to know the influence. What does that mean? How does it influence, right? The external factors, okay, the influence of external factors on the rate of transpiration. Now, you need to go back to the last lesson. What things outside of the leaf will cause the leaf to transpire quickly? That's the influence. Does it slow it down or does it speed it up? I'm giving you 1 minute, right? I want you to quickly over here, right, jot down what were the external factors, and there's about 4 of them that we are going to test today, that are going to influence how quickly or how slowly transpiration occurs. Your time starts now. Hope you remembered what the external forces were that affect transpiration. Okay, your answer should have been the following. Okay, humidity. In other words, how much water vapor is in the air. Okay, light intensity. Wind. Right, and the last one is going to be temperature. Okay, those are the four. Also, amount of soil. Okay, soil water there is, so the amount of water there is in the soil. But we are going to look at these four are going to be the factors that we are going to test. Okay, so now my method, what do? All right, my method is setting up my petometer. I explained to you how to set up the petometer, all right, and that is what we are going to do. Now, my whole aim, let's go back to the aim, is how do the external factors influence transpiration? So in my laboratory, there or in my classroom, I need to have wind, high temperatures, high humidity, and high light intensity. I need to have all of those factors, right, in my experiment. So obviously, I've got to use things that I might have available. Can any of you, all right, think of what I'm going to need? All right. So we need to test for these. Okay. Can any of you think, all right, can any of you think, I'm going to go here, let's go back to it. Oh, we're going to find it now. Oh, there we go, almost gave it away. Right, can you think of the equipment that we can use to imitate this condition? In other words, what would I use for wind? What would I use to increase the temperature? What would I use, right, to make it humid? And what would I use for a bright light? Okay, I'm sure some of you have come up with an answer. You are quite correct. Okay, what am I going to use? For a wind, I can use a fan. For high temperatures, I can have a heater. For high light intensity, I shine a very bright light, very close. And high humidity, I put a plastic bag around the twig. Why do I put a plastic bag? What did I say to you? The plastic bag is going to collect all that water. Okay, so what am I going to do? The first thing I'm going to do is I'm going to set up a table. Why do I set up a table? I need to draw up my results. Okay, and here I have a table for you. Because what we're going to measure, as I said to you, we are going, these things, that air bubble that's going to move, we're going to time it. So what we're going to do is we're going to take that air bubble and we're going to start the stopwatch and we're going to take 1 minute and we're going to see how far that air bubble travels in 1 minute. Okay? So maybe I get 2 centimeters. Right, maybe the next one I get 3 centimeters or 2 centimeters. So what I do is I do the test 3 times each, because what I need to get at the end is I need to get an average. So I add all of them up. So I add all of that, I get an answer, and then I divide by 3 because I want to get my average, because that's what we're going to do. Okay, so I've set up my table, and now I'm going to take each of those external factors and I'm going to test it. Okay, so how do I set up? Here's my petometer. I've set it up. There's my air bubble. Okay, here I've got my fan. And what does my fan do? My fan is going to put wind onto the plant. I start my stopwatch, and then for a minute I see how much does my air bubble move. Then I record it. Then I wait a little bit, and then I do it again. And what I do is each time, by using the control of this little knobby, I can get my air bubble to move back again, so I can start again. And so I'm going to do this for each of my external factors. I'm going to take my fan, and I'm going to conduct the experiment 3 times, and I'm going to record in my table. I'm going to take a heater for high temperatures, and I'm going to put it in front, and I'm going to conduct my experiment 3 times. All right, I'm going to take the next one, I'm going to take a bright light. There we go, nice and easy. All things that are quite easily obtainable. The bright light for light intensity, and I'm going to do the experiment 3 times. The last one, right, I'm going to put a plastic bag, as I showed you in this petometer over here. I put a plastic bag because the water is going to create water vapor, which is humid conditions. And once again, I am then going to take my results. From my results, right, what do I then need to do? I'm going to take my results, and I'm then going to make an observation. And from that observation, the chances are that you will probably have the following, right, results. But even if you don't get the results, your conclusion is always based on what happened, right? What happened. What probably might have happened was that for wind, high temperature, and high light intensity, your bubble moved quite fast. All right? Your bubble moved quite fast because wind, high temperatures, and high light intensity causes transpiration to usually increase. Okay? Because here's my stomata. There we go. The water goes out very quickly, and as soon as the water goes out, it needs to be replaced. High humidity, you might have seen that your air bubble moved quite slowly. And from that, we can conclude that high humidity decreases the rate of transpiration. Whereas wind, high temperature, and high light intensity increased the rate of transpiration. Okay, so remember a petometer, and we're measuring the external factors. We're going to have a quick break, and when we come back, we're going to have a look at how we can answer questions relating to experiments on transpiration. Have a quick stretch, and we'll be right back. Welcome back from the stretchy. Right, we're going to go straight into the questions. Okay, now we're not going to ask you, right, we're not going to ask you that experiment. We can set it up and we can ask you what happens, but very often we can use the principles, right, those conclusions from your experiment, right, to be able to answer questions that are going to come up. Okay, let's start with the first question. The question says, the effect of increasing light intensity, remember that is an external factor, on the rate of transpiration, all right, so the effect of increasing, so we are getting, it's becoming very bright, on the rate of transpiration, which is the speed, so how quickly or how slowly what is going to occur, from upper and lower surfaces. All right, that is important because we need to look at the structure of the leaf here. You need to think of that. Of similar aged leaves of a plant was investigated. Similar age tells me, all right, it's a controlled variable. All right, what am I I'm controlling it. I need things to be as consistent. The last part of it, all other external factors were kept constant. Okay, now there's a graph, all right? Have a look at my graph. The mean average, the average results from a number of leaves were indicated below. So what we have at the bottom here is light intensity. So that's how bright my light is, okay? Here is rate of transpiration, which means the speed. So this would obviously be quite slow, going up to the top, which obviously then would be much faster. Okay, so this is the graph. Now from this graph, we can see a few things. Also have a look, lower surface and upper surface. Okay, lower, bottom, upper at the top. So what kind of questions can we ask over here? All right, let me go. If we have a look at the first one, I'm going to give you 2 minutes. And what I want you to do, I'm just going to get you to do this one, and then I'm going to do some of the rest with you. I would like you to do questions 1 to 4. I'm going to give you 2 minutes to do it. And I'm going to swap between the question and the graph. The question and the graph. So look at the question first, then I'm going to swap it to the graph. Okay? You guys have got 2 minutes. 2 minutes. See if you can look at the graph and match the questions that need to be, all right, or look at the questions that need to be asked. Your time starts now. Were you able to look at the results from the table and be able to match it to the questions? Right, let's go and have a look quickly to see how well you did. I think I can go over here. All right, let's have a look at the graph again. Okay, the first question was, list 2 external factors which should be kept constant. Now, we've just done it. The external factors were, all right, the one now, light intensity, temperature, humidity, and wind. Now, those 4 that we've done, it says list 2 external factors. Now, if we go back to our diagram, I hope you didn't write light intensity, because what are we trying to see? We actually want to change light intensity. It says all other external factors were kept constant. Constant means the same. So from your answer, if you got light intensity, all right, that was incorrect, because that is what we're actually changing. So you could have had temperature, right? You could have had wind. You would have had humidity. Humidity. Okay, any of those three would have been, all right, the correct answer. 2 out of those 3. Now question 1.2. State the effect of increasing the light intensity from 0 to 1. So we go back to our graph, right? There is 0 and there is 0,1 over here. Now, no matter which of your surfaces, they didn't ask you for upper or lower, all right? They said to you, what effect, here was 0, okay? I made it brighter. When I made it brighter, what happened to the rate of transpiration? What does my graph do? It starts to show an incline. Okay, so what effect is happening? State the obvious, it's for 2 marks. Okay, an increase in light intensity, there's your, all right, light intensity, intensity, which is your independent variable, it's the one that you chose, will, all right, cause an increase in rate of transpiration. Right, let's have a look at the graph again. Look here. Remember now, when we look at our graph, what are we looking at? Light intensity, that's what I chose, independent. The results are always on the y-axis, that's the dependent. When I increase the light intensity, look what happened to the rate of transpiration. It increased. Okay, so what's that telling me? The more light I have, the more, all right, the greater or the more the rate, the speed, the quicker transpiration is going to occur. Okay, the next question. Next question. Give a possible reason, possible means a probable, it must make sense, for the change in the effect of increasing light intensity above 0,1 on the rate of transpiration from the upper surface. Now let's go back here. All right, first of all, we have to look at the upper surface. What did you notice? Okay, as my light intensity, they're asking you to describe what is happening. And you should have noticed, even it's the upper and the lower one, right, that the upper surface, it starts to level off. Right, it starts to level off. What does that mean? That it matters, no matter how bright or how brighter the light is, transpiration, right, is only going to be able to happen so quickly. Right, it can't just go up exponentially. It reaches a point where it's going to stabilize. So the question asks you over here, give a possible reason for the change in the effect of increasing light intensity above 0,1 on the rate of transpiration from the upper surface. Now, if you will go, right, if you're going to have a look, and the next question actually helps with that explanation a bit more. The upper and the lower surface of the leaf. On the upper surface of the leaf, all right, remember when you did your leaf, what do you not have? You do not have a stomata. On the lower surface of the leaf, what do you have? Stomata. Okay? So where does transpiration usually occur? On the lower surface. So, because it occurs on the lower surface, we would expect the result, all right? We would expect the result to be higher than the upper surface. So, what we're going to see is, on the upper surface, why does it level off? All right? Why does it not continue increasing? That's the reason. And the possible reason is that it does not have. Now, not some leaves do have stomata. So it does not have or does not have many stomata. All right. And because it doesn't have many stomata, right, the rate of transpiration will be less. Okay, right, and what we also have, right, what do we also have on the top? Right, on the top of the leaf, we have a cuticle. And that waterproof cuticle could also have an effect, right, on decreasing the rate of transpiration. Okay, so leading from that, leading from our question number 3 to question number 4, have a look here. I think we've answered almost. Give an explanation for the difference in the rate of transpiration between the upper and the lower surfaces. Now, there's a few things that you could have come into being here. Let's go back here. What did we notice? That my upper surface had a lower rate of transpiration than my lower surface. And when we looked at the diagram of the leaf, what did we see? That stomata are usually found at the bottom. Okay, stomata are usually found at the bottom. So give an explanation for the differences in the rate. You would say, explain the difference. The upper surfaces have lower rates of transpiration than, first of all, give the relationship, than the lower surfaces. And your reason being, the lower surfaces have more stomata, okay, have more stomata. And where does water move out? All right, which means that it loses, right, it loses far more water. Okay, so from that, as I said to you, you're linking it to the structure of the leaf. So the structure of the leaf, right, so when we look at transpiration, you cannot only know, all right, what the whole transpiration is. You've got to go back to what does the leaf look like, right? So when I'm given upper and lower, the reason I know that I can know that the lower one is because that's where I'm going to find the stomata. Right, and also another thing you could have said, that why the top one starts to lose right in the beginning is that because it receives more sunlight, because it's on the top. I'm afraid that's all that we have time for today. Thank you so much for tuning in, and I'm looking forward to seeing you next time. Cheerio, bye.